Okay, good morning, guys. Good morning. So, welcome to our class 13. We're going to talk about writing for a non-science audience today. So first, I want to show you on Canvas kind of where we are in the semester so far, what we have going on. So again, we're all the way. Last week, we talked about CVs and your asynchronous material involved science posters and making a draft of that. This week's material is about writing and talking to the non-science community about science. And so today's class will focus on the writing element, and you'll write a blog post based on an article. So if you look at your week 13 assignment, it's an article similar to what we've been doing in class of reading, but you need to write a blog post about it with at least 2 visuals. What I'm expecting are you'll take the figures from the paper that you think are the most important, the most relevant, put those in to the post, about 350 words, and you're summarizing and analyzing it just like you did for class, but you're using what we'll talk about today to make it for a non-science, more general audience. And then go back, so page load its thing. Then you'll watch a video or look at a PowerPoint about talking about science rather, and social media for science. And you'll make a video and some tweets about a different paper. So here's a paper about climate change. I'm asking that you write 2 tweets about the paper and then make a really short video. You can post the video on YouTube or submit the video file directly, whichever works best for you. Just briefly talking about that article. Then you've got another journal post, and then next week will be kind of our final real week. We're going to do another writing workshop. I'm asking that you email documents just like you did for the lab report workshop to that same person. You email your personal statement, your CV or your resume, whichever one you worked on, and your science poster. And then you use these rubrics to help provide your partner with some feedbacks about your draft. When you come to class next week, I'll put you guys again into those breakout rooms with that partner, and you'll go through your drafts and just give each other feedback on them. And then your asynchronous material is just to write. So you're going to submit your peer reviews, and then you have a journal prompt. You're going to just work on your final documents. The last week of class is supposed to be a half week, and instead I want you guys just to focus on some self-care and on getting all of your documents together. So your final writing portfolio is due either the last week of class into finals week. So it's those 2 lab reports. I want you guys to give me the best version you can, right? Taking into account my feedback, your peers' feedback, the rubric. Really make it as polished as possible. A personal statement, a CV or resume, and then that science poster. And then in finals week, we'll have our virtual poster session. Okay, so that is where we are headed. Here's where we are. We're in our class 13 agenda. So for the class 13 attendance quiz, I want you guys to give me just the top 3 words that you think about when you think of science writing. So what 3 words come to your mind when you think about science writing? And then after you put them in the quiz, you also want to put them in the chat. So what do you think about when you think of science writing? Do that. I'm going to prep up.
Sorry, can you say that one more time?
What 3 words come to mind when you think about science writing? So we've read some examples of science writing this semester. What do you think about science writing? What words come to mind? So put those in the quiz, and then also put them in the chat. We'll give everyone a minute or 2 here. Okay, so let's see what some of our responses are. So Caleb says factual, results, data. Okay, Evie says hypothesis, scientific, educational. All hopefully true. Hopefully true. And think about, you know, all of the science papers we've had to read this semester, right? Those are classic examples of science writing. Kristen says research, random, professional. Okay. Experiments, hypothesis, and results. Let's see what else, a few others, and then we'll get started. Give everyone that last minute here. Okay, so these are generally very positive. You guys are nice. Okay, so we're going to talk about how to write for a non-science audience. So all semester we've been focusing on writing for scientists. So Raquel says formal, real experiments. Those are also very, very positive, I would say either neutral or positive comments. We've been talking about writing for scientists, but it's also important to convey scientific results to people who are not scientists. Amy's getting a little more real here. She says wordy. Yes, wordy, but also factual and stimulating, which are again more positive terms. Our learning objectives today are going to be to identify the goals of a writing assignment, to simplify confusing jargon, which oftentimes comes up in science writing, to determine an appropriate level based on the audience, to engage the reader with clear writing. So let's think about these questions. What do you think of scientists? What do you think of science writing? What topics do people need to hear from scientists? You guys told me what you thought about science writing. Now, when you ask the general public what they think about science writing, you'll get more words like boring or overdone, confusing, full of jargon, right? Wordy. Science writing is often not clear. And you guys know this. We read some more complicated papers this semester where, yeah, it was challenging. And you guys are all biology majors, so you are all in the field of science. You're trained in science. You have a background in biology, and even for you guys, some of these papers were tough. For me, they were tough. It's science writing is not always clear, and scientists can often be insular and focused on their own very small area of research. Maybe they only communicate with other scientists. Maybe they only think about that paradigm. But there are some really important topics that people need to hear from scientists. Can you guys in the chat give me an example of a topic you think it's really important to hear from scientists, or really important to hear from experts in general? There are lots of them for today's day and age. Let's see what you guys come up with. In vaccines, yeah. All sorts of vaccines, not just COVID vaccines, but there has been so much debate about vaccine schedules and different types of vaccines and the flu shot, healthcare in general, right? These are topics that we need expert opinions, and we need to hear from experts and have that communication open between the public and from experts. Any other topics that come to mind for you guys? Education, yeah, that's more in the social science realm, but still, yes, education is a topic where we need experts, new treatments. You can talk about COVID, climate change, yes, the environment, exactly. So there are a lot of complicated things going on in our world, and we need to hear for ongoing studies, yes, from experts, from scientists. But there is a gap that exists between scientists and the public, and a huge part of that is communication, is that science writing can be confusing, it can be boring, it can be hard to understand, hard to access. And so as people engaged in the field, we need to work on communicating not just for other scientists in the form of lab reports and articles, which you guys are now experts on, but also communicating for the non-science audience or the general audience. And when I say general audience, I don't mean someone who is a child. So I'm not asking you to write to a first grader. I'm asking you to write to someone who has, you're going to assume a general education, but they might not have a biology background. So that's a caveat. Okay, so there is a research centers, so the Pew Research Center does these really great polls about what people think. And they're very well respected for their polls. They're nonpartisan, non-biased. And some of the recent ones they did is about who the public trusts, right? Because this is, again, we're talking about experts. A lot of that is who do you trust? And in general, people seem to trust or at least value scientific research. And so they asked what percent of them think that the government should invest in scientific research, or government investments in science research are usually worthwhile. And the average around the world was 82%. So a high proportion of people think we should be spending money on science research. It's very important to be a world leader in scientific achievements, a little bit less there. Our scientific achievements are the best, even a little bit less. They have a lot of trust in scientists to do what is right for the survey public. So this is the one where I found it a little scary, right? Only 36% of people globally in the world have trust in science, in scientists to do what is right, okay? And in a lot of countries, what we're seeing is a growing political divide, where conservatives seem to have less trust in science and scientists than liberals do. And so this survey polled conservatives and liberals and people who are moderates, and it saw this political spectrum divide on questions like, do you have a lot of trust in scientists to do what is right? Do scientists make judgments based only on facts? And to solve problems, the survey public should rely more on people who consider themselves experts. And for me, this is maybe the most troubling, that only 43% of liberals and 23% of moderates and conservatives think that you should rely on people who are considered experts, right? So as we've discovered in this class, expert status means something when we're talking about science. Reading those papers has shown you that these experiments are complicated. And so it's not that anyone can open up a scientific journal and read it and completely understand everything that goes on in there. And so you need someone who has a background, even someone like yourselves. You guys are going to have a bachelor's of science. And so you'll have a background in science that allows you to understand more than someone maybe who was in the English department or another non-science department. And so I really hope one of the things you walk away from this class understanding is the value of experts. The other research study that they did was they surveyed the general public, but they also surveyed AAAS scientists. So these are National Academy scientists. They're not just like me, like an everyday scientist. I would call myself more of the everyday scientist. These are like the cream of the crop experts. And they surveyed them about different questions. And what you can see is there are some topics that there's a big gap between what the public thinks and what scientists think. So for example, 88% of scientists believe that it is safe to eat genetically modified foods, where only 37% of the general public believe that. So that's a very big divide. There's also a big divide on using animals in research and using pesticides to grow food. And then for me, another disturbing one is that climate change is due to human activity. So 87% of surveyed scientists believe that, and only 50% of the general public believe that. And we see that more recently when we look at data on the COVID vaccine, which we don't have one yet, but trust in that and trust in the scientific process is falling. So even from May to September, across the political spectrum, we see that fewer and fewer people say now that they're going to get the COVID vaccine if it becomes available today. And for me, a lot of that I relate to distrust in scientists and not understanding the scientific method, not understanding what scientists are saying, and not relying on expert opinion for that. And so one way that we can bridge that gap is through science communication. So we need science communicators. This is a real job. If this is something that you find yourself passionate about, this is an actual job that exists in a lot of places called science communicators. And these are people who understand the science. Usually they have a master's, but sometimes they just have a bachelor's. But they also are really good communicators, both in the written and the oral form. And they're able to take in scientific information in the form of reading papers and then synthesize them and analyze them and convey that information clearly to the general populace. So let's talk about what we do when we're writing for the public. When we're writing for the public, we need to do the following things. We need to, sorry, my thing is off. There we go. We need to catch people's attention in the first sentence. So science readers are reading an article for a reason. For you guys, you were reading an article because I assigned it to you. But in general, a scientist is going to read an article to gain knowledge because they want to learn a new technique, because they know the author, because they're going to go hear the author speak, because they're going to a conference, right? Because it's in their field. And they're going to read probably the whole article from beginning to end because they're hoping to gain something from that. The public, on the other hand, has a very short attention span. And so you want to catch their interest with an engaging first sentence. So here are some examples. To put all human knowledge at everyone's fingertips, that was the grandiose vision of Paul Otlet, a Belgian librarian and entrepreneur. Charles Darwin's voyage aboard the Beagle is legendary in the history of science. And yet, one of his notable observations is barely known. Ooh, intriguing, right? You want to know more. You're hooked. You want to pay attention. So you want to use an engaging first sentence, especially when you're writing for a non-science audience. And again, this doesn't mean an uneducated audience. These sentences contain some not easy vocab words, things like grandiose, for example. That's a complicated word. So you can use big words even when you're not writing for a science audience. It can still be a well-constructed, well-written document. You want to know where you are taking your reader, and then you want to show them with examples. The best way to do that is to provide a story to illustrate what is at stake, some sort of anecdote. It makes the science relevant. For scientists, we really just want the numbers. We want the data upon data upon data. We want all of the figures. Show me your tables, show me your graphs, give me all of the numbers, run a bunch of statistical analyses on these numbers, tell me all that statistics. That's what we want. For people, though, for the general public, numbers are boring. If you just read a paper and it was a sea of numbers, a scientist would be like, bravo, look at all that hard work. A non-scientist would be like, why do I care about these numbers? The way to make someone care is to give a story. And after you give that story and you make the science relevant, then you can scaffold your thesis and explain what you're going to talk about in that post or in that paper. A great example I linked below is about a fatal neurological disorder. Now, I'm a neuroscientist. I've written papers about brain disorders before. Again, I normally just put a lot of data and numbers and facts. This paper, however, starts off with a really catching and engaging story of someone who has this disorder. And so it makes it relevant for the general public. You want to assume your reader is skimming. You don't have to tell me this because I know it. I know most of you guys skim when you read science papers. It's okay. I know you skim when you read anything, right? You're just kind of glazing through. And so what you want to do when you're writing for a non-science audience is assume they're like you. They're just kind of skimming it. You want to use subsection titles to draw them back in, use headers, and then treat the first sentence of every paragraph in a subsection as a place to hook them back in. So make sure those are especially engaging. You also want to make your paragraphs small because when you're skimming and you see a giant paragraph, it can be a little intimidating and you're going to skim faster. Break it down, right, so it's more digestible. Don't open with a question. These are my least favorite ways that people open paragraphs. You know, the scientific method is all about questions. It's all about questions that lead to hypotheses, that lead to experiments, but don't make your topic sentence a question because it can lead the reader to assume that something that might not be a question is a question, right? For example, if you're writing a paper about climate change, you might think a great way to start would be like, is climate change caused by man? And you're going to open with that question, and for you it's rhetorical because the answer is obviously yes, climate change is caused by man. But your reader might assume that it's not rhetorical, that that still is a question, that it's still open for debate. It's more important to instead state the topic. Instead of saying, is climate change caused by man? Or what causes climate change? Say, climate change is caused by human activity, period. This is a problem that scientists do a lot. For us, we leave the uncertainty and we understand that if we say we're 99.9% sure that this is what's happening, that we're just leaving that little bit because that's how science works. You have a little bit of error, right? The p-value is not p=0, it's p=0.001. There is a chance that the null hypothesis is true, but it's a small percent. And for a science audience, we'd be like, I feel great about that. For a non-science audience, they see that uncertainty as doubt, and they would interpret that as, well, you don't understand, or you don't know, or my opinion is still valid. No, we do know, we're just leaving room because that's how scientists phrase things, that little room for error. When you're writing for a non-science audience, transitions matter. You really want to make sure subsections flow. Again, assume your reader is skimming, and so you want to make sure that you're connecting the topics for them in case they jump in the middle. So pull them along for the ride. Here you want to write in the first person. We've spent a lot of time this semester talking about the third person. The scientist poured the water into the beaker and then dumped it into their mask. Now we want to switch to first so that we can engage the reader directly. I feel this way, I observed this, etc. You want to give examples about real people. Again, you want to connect and underscore why a topic is important. And write examples about people affected by that topic. That's a great way to do it. Numbers are great, but stories matter more here. You want to avoid jargon. This is one of the main problems with science writing. When we're talking in an in-group, we might use a bunch of words that no one else understands. You want to cut out words that someone would need a college degree in that topic to know. And if the word is necessary, you want to define it for them. So say you're reporting on a paper about cancer, right? Everyone knows what cancer is. You don't have to define cancer, but you're maybe talking about a drug that leads to apoptosis. Apoptosis is important to understand what this drug does. So you want to define apoptosis for your audience. Assume that they don't know that apoptosis is programmed to cell death, for example. You want to use a conclusion to draw the reader forward. So in science writing, a lot of times we'll use the conclusion as a place just kind of summarize, but here is your opportunity to put the problem in a greater context. So you wrap up the loose ends and then you look to the future. Why is this important? Where do we go from here? What should the next steps be? Why should we care? What is your opinion about this topic? Look to the future. And that will help draw a hopeful narrative, a hopeful arc for your reader. No passive voice. I hate passive voice. I've said this all semester, but here especially, no passive voice, no clunky sentences. When you finish your document, you should read it out loud and it should flow nicely. Okay, it's gonna be your turn. You're gonna write a blog post. So science writing, science communicating, super important. For this class, we're gonna be focusing on science writing and then science communication in the oral form. And the video I made in the PowerPoint talk a lot about social media because that has become the avenue that people use to discuss science. So with that, we've finished the topic for today. I want to give you guys time to write and do these things because the two articles that you need to synthesize for the blog post and for the videos and tweets, they're long. They're each about 15 pages. So it's a fairly large assignment, so please make sure you give yourself time to do both of those and do them well. And then again, before next week, before next Wednesday, you're gonna need to email out the drafts of your other 3 documents, your personal statement, your resume, CV, and your science poster to your partner so that they can give feedback for that. Do you guys have any questions? Okay, you guys are good to go. I'll stick around if you do have questions, and then otherwise I will see you next week for our writing workshop.